Okay, in chapter 6.3, we're discussing areas, moving on from perimeters to discuss areas. And let's start out by looking at squares and rectangles. Okay, here is a rectangle. Let's put squares and rectangles here. So this has some width, let's say 3, some length, 4. What's the area of this rectangle? Well, before what we did is we broke it down into units. So we have 3 separations horizontally and 4 vertically. And before what we did is we just counted the number of blocks we had. And if you see, we count these 1, 2, 3, 4, 8, 12. We see that the area is in fact equal to 12. But we don't have to do that. What we can do is just simply take, for the area, we can take the width and multiply it by the length of our rectangle. So 3 times 4 equals 12. And in a simple problem like this, that might not be that big a deal, but if you had hundreds and hundreds and hundreds of blocks to count, it might just be easier to take the side, the length of 4, multiply it by 3, or the length of 4,000, multiply it by 3,000, so on and so forth. So for a square, our length and width are the same. So the area equals side times side, or side squared. And again, for a rectangle, again, the area is length times width. Okay, so let's look at some other shapes. How about a parallelogram? Maybe this parallelogram has a base length of L. Well, again, let's use our ideas that we've learned already. The idea for a rectangle. If we're clever, we can see that if I do a vertical cut like I did with this yellow line here, then this angle here is 90 degrees. Now, if I were to take this triangular section here and bring it over here, you'll see that this extension down here is exactly the same as what I cut off over here. This one over here, it's exactly the same length. So I didn't change the overall length of this bottom line. So it is still length L. But now you see that I have kind of constructed a rectangle. So this height here, the perpendicular distance between the two lines, the height here, and the length we can use to figure out the area of this parallelogram. So this is length times height. So we have to figure out what that height is. I've redrawn my parallelogram the way it was before so as not to mess the notes up. So it either has to be given in the problem or we have to be able to calculate what it is. So suppose I have a parallelogram. The top and the bottom are parallel. They both have length of 5. These have some undetermined length, these angled values, but the distance between the top and the bottom is 2. So you know this is going to be a little longer than 2 because it's the hypotenuse of a triangle. But anyways, the area for this is just 5 times 2 equals 10. Okay, how about a triangle? Well, let's look at a right triangle first here. Right triangle, we have a 90-degree angle in our triangle. How can we figure out what the area of that is? If we know, say we know what the base length is and the height length is, how can we figure out the area of that? Well, we can play a little trick like we just did. See if you guess it. Maybe you pause and see if you guess what the little trick is. So here's a trick. We make a copy of that, an exact duplicate of it. Now we take that and I rotate that around 180 degrees, like this. Now I take it back, and you can see I can fit it exactly in here, and we turn this into a rectangle. And we know what the area of a rectangle is. So area equals of a rectangle is base times height. But here, the thing is that this portion that I've moved off to the left here doesn't actually exist. So we have to take away a half. So the area really of this triangle is only 1/2 base times height. Well, it turns out this is actually the area of all triangles, not just right triangles. So say I have another triangle over here. So here I have an equilateral triangle, or it could just be any triangle that is not a right triangle. How could I figure out the area of this? Well, I'm going to monkey around with it again, see if you can do it. Give you a second. Okay. Pause and you've come back and you're successful. Good job. If not, here is what we could do. We could make a copy of this. And I will rotate it again. 180 degrees. Now I will fit it up against here. And you can see that we have a parallelogram. And the area of the parallelogram was 1/2 base times height. But the base is, of course, this distance. And our height is perpendicular distance between the two parallel lines, if you recall. Here I move the triangles away again, and I put arrows on them. So now you have to figure out what this height is, and it's a line perpendicular to the base here. So that has to either be given in the problem or you have to figure out what it is. But again, the formula is area is 1/2 base times height, just like this one. Now what if I have an obtuse triangle? Then what do I do? Again, pause, see if you can figure it out. Okay, if you did it, or if you just want me to tell you how to do it, here's what you do. Again, we copy the triangle, and then, as you guessed it, might have guessed, we rotate again 180 degrees, and this time when I fit this together, you can see that this will be a parallelogram. So I've got this really light, and what we need to do now is we need to find the height, or the perpendicular distance from the base here. So we need to find the height here, and we use this as our base still. But we either need to be given this height or we need to find the height. So again, the area equals 1/2. Since it's parallelogram, 1/2 base times height. Since it's not two triangles, it's just one triangle, so it's half of this area of a parallelogram. So I'll write it big here, 1/2 base times height. There's always a dog barking. Okay, going to get a little more tricky. Here's a trapezoid. Let's see if we can't figure this out. Okay, here's how you do it. Now this one, you might have done it differently than what I'm going to do. But here's what I'm going to do. I'm going to take this trapezoid and I'm going to cut it along this diagonal here so that I have two triangles. So now all I have to do is figure out the area of two triangles. So I have one triangle with base 1, another triangle up here, and it's going to be easier for me if I consider this the base of it upside down. Notice that this base and this base are parallel. So I have area 1 and area 2. So what am I going to do here? First thing I'm going to do is I'm going to take area 1. Area 1 is probably the easy one. So the total area actually is equal to area 1 plus area 2. It's the area of the two triangles. So area 1. So area 1 is 1/2 base times some height. And that height is this here. It's the perpendicular distance from the base to the top of the triangle. So this is our height. So you either have to know what that height is, or you have to figure it out. Either has to be given in the problem or you have to figure it out. So for our next area, again, it's a triangle, so this is going to be 1/2 base times height, but the base 2, I'm doing fat now, I don't want to be fat. Base 2 is this top line up here. And the height of this triangle, well, if this is the base, then the distance from here to here is the height, which is the same height that I have over here. So, okay, let's simplify this a little bit. We can distribute out. We can pull out the 1/2 and the h, 1/2 times h, and we're left with b1 plus b2. So that's the area of a trapezoid.